In this lesson, we're going to review how to use trig ratios to solve for unknown sides in triangles. So in the last lesson, we solved triangles where we knew two of the sides and we were looking for the third side. But sometimes you may only know one of the sides of a triangle, but you may also know one of the angles inside of it. So in right triangles, we can use trig ratios. Now these trig ratios you've learned in the past, hopefully. We remember them using the acronym SOHCAHTOA, and that's a way of remembering which ratio goes with which trig function. So just a quick review. Remember that we always name our sides based on their relationship to an angle. So for example, in this image here, I am referring to this angle A. It's called theta, that's what this symbol is, theta. And we would name the sides in our triangle in relationship to that angle. Now, the good news is, from the last lesson, hypotenuse is still the one across from the right angle. It's the longest side in the triangle. No matter what triangle you have, your hypotenuse will be this side across from the right angle. But the opposite and the adjacent will change depending on which angle you're looking at. So from this angle theta, this side BC is opposite because it is across from the angle. And this side AC is adjacent because it shares a side. It is used to form one side of the triangle. So this is the adjacent. And like I said, side AB is the hypotenuse. So depending what sides you have and what sides you're solving for, you're going to use different ratios. So down below here, we have all of the ratios. Sine theta will always be equal to the length of the opposite over the length of the hypotenuse. So some different variations that you may see. Abbreviated a little bit, op over hypotenuse. And here sine is O over H. In SOHCAHTOA, this is so. It's a way of remembering that opposite and hypotenuse go with sine. Cosine is the adjacent over the hypotenuse. So again, in our SOHCAHTOA, cos is adjacent over hypotenuse. And tan is opposite over adjacent. So we can use these ratios to solve for either unknown angles or unknown sides. In this lesson, we're going to focus on solving for unknown side lengths. So the first step whenever you look at an example is to first figure out what sides you've been given and what sides you're looking for in the triangle. So this is the angle we've been given. It's angle C, it's 60 degrees. So I'm going to begin by labeling my sides in relation to this angle. So from angle 60, this 10 is the hypotenuse. It's across from the right angle. It's the longest side in the triangle. And this side X is the opposite because it's across from the 60 degrees. Once you've labeled the sides, so this side down here would be the adjacent. I'm not worrying about it too much because the hypotenuse is the side that I know and the opposite is the side that I'm looking for. So those are the sides that matter. I don't know the length of the adjacent and I don't want to know or need to find the length of the adjacent. So I'm not going to worry about it. Once you've labeled your sides, you can see you've got hypotenuse and opposite. So in SOHCAHTOA, you want to find the ratio that uses opposite and hypotenuse, which is sine. So that means we are going to use sine theta equals opposite over hypotenuse. And now I need to plug in the values that I know. So I know the angle theta is 60. So this is the angle. So sine of 60 degrees will be equal to, the opposite is unknown, and the hypotenuse is 10. Now I need to solve for x. So you're going to need a calculator, and in order to solve for x, you need to get rid of that dividing by 10. So in order to do the opposite of dividing by 10, we are going to multiply by 10. And whatever I do on one side, I have to do to the other. So it means I'm going to do 10 times sine 60. These will cancel out so that I'm just left with x. Now on your calculator, you need to make sure your calculator, make a note of this, is set to degrees. So on most calculators, there will be a button. So on my calculator, it's this button here, DRG. And you can see on the screen, maybe, that there's a little symbol here. It says DEG. It means my calculator is set to degrees. So I'm then going to do 10 times sine 60. And when I do that, I get 8.66. So 8.66 is the length of side x. It's a good idea when you're doing this to also look at your triangle. 8.66 and the hypotenuse is 10. That seems like a reasonable length. If I got a side length of 400 or 1,000, I might question and make sure I didn't make an error, but 8.66 seems like a reasonable length for this side of the triangle. So that is our answer. So similarly, in example 2, I've got an angle here of 35. That's theta, the angle I'm working with. Now, if I label my sides, I always label my hypotenuse first. So this is hypotenuse. But now I'm looking for side x, which in relation to this angle is the adjacent. So when I look at SOHCAHTOA up here, I'm looking for which one uses A and H, which is cosine. So cosine theta equals adjacent over hypotenuse. So cosine of 35 degrees equals the unknown over 21. And in this case, my steps are very similar. Again, I need to multiply by 21 to isolate the variable. So in the calculator, I'm going to do 21 times cos 35. Get 17.2 equals x. Again, if in the question it had feet or centimeters or meters, you would want to make sure you include that unit. Last but not least, I've got this triangle. I've got the angle 52, which is theta. I'm going to label my sides. So the side that I know is across from the angle, that's the opposite. And the side that I'm looking for is right beside the angle. It's not across from the right angle, so this would be the adjacent. So in SOHCAHTOA, this is tan. So tan theta is the opposite over the adjacent. So tan of 52 equals 36 over x. Now this one's a little different. The steps for solving are slightly different, but what we would have to do is we would have to multiply this side by x, but then we would need to divide by tan 52. The easiest way to remember this is that when the x is underneath, we can just switch these two around. So x will be equal to 36 over tan 52. So in my calculator, 36 divided by tan 52. And x would be equal to 28.13 Again, there's no units, so that is good just like that. So that's how we use, that's it for the examples, that's how we use trig ratios to solve for unknown sides.